We don't farm the way we used to. One of the reasons is because there's no labor. Farmers over the last 2 years have lost $42 billion just in rural, regional income. And so that's disappearing, and we want to stop it.
Welcome back to the Purdue Commercial AgCast and our Lessons from the Delta series. I'm Chad Fiechter, and Todd and I spent several days traveling through the Mississippi Delta last summer. During the trip, we spent a lot of time visiting research stations, farms, and talking with producers about how agriculture works in this part of the country. But every once in a while when you're traveling around farms, you run into something you don't expect. While we were visiting one of the farms near Augusta, Arkansas, we noticed a group of people working with a small, odd-looking machine in a field. That's when we met Sarah Hinkley. Sarah is the CEO and co-founder of Barn Owl Precision Ag, commonly called BOPA, a company building small autonomous farm robots designed to move through fields and perform precision weeding between plants. You can learn more about the company and robot at barnowlag.com. It turned into a fascinating conversation about robotics, labor challenges in agriculture, and what farm automation might actually look like in the field. So in this episode, we're sharing an unexpected conversation from the field about farm robotics.
We're here in this field. We just told people that we had this serendipitous moment where we found you. So who are you and what are you doing?
Yeah, I'm Sarah. I'm the CEO and co-founder of a company called Barn Owl Precision Ag. We go by BOPA. And we are building the autonomous Nano tractor, which is a small farm robot designed for precision weeding in between the plants.
Okay, and what are you doing here today?
We got started originally in Colorado, and we're part of a program called Ag Launch, and they help us to expand our technology with farmers who are interested to try it all over the country. So Sean is one of the farmers who wanted to try it, and here we are, figuring it out.
So a couple of things that you've said that we need to talk about. One is, what is unique about your company?
Our company has taken the approach of really trying to balance the high advanced technology with a budget that makes sense for the farm. And so we have taken advanced technology and we've tried to integrate it in practical ways. Our tool is one of the only ones who can get through late stage weeds, and that's critical for farmers. And then our tool, the robot itself, is the only one that can kind of be adjustable and manage different environments.
Okay. The other thing is you've chosen a color scheme. What is the color scheme that you've chosen?
Yeah, we, all the bright, high-vis oranges and yellows were already taken, so we went with hot pink. We're one of the only, probably, but one of few woman-run ag tech companies in the industry right now, and so we figured lean into it, and we have had zero negative farmer feedback from it. One of our farmers who gives us heck about everything, but otherwise, They love it.
They're just complainers. Yeah, okay. All right. So the other thing is you have some connection to this geographic area. What is that?
Yeah. So my family is from the Batesville area, which is just about an hour away from this farm here in Augusta. We come from the farm, so we've had a long history of farming and ranching in Arkansas all the way through Tennessee and Missouri. And then in Colorado, we also had a small operation, but my grandparents, their kids went off to college to Denver and just kind of never came home. So we don't farm the way we used to anymore, and one of the reasons is because there's no labor, because inflation, and farmers over the last 2 years have lost $42 billion just in rural, regional income. And so that's disappearing, and we want to stop it.
And that's cool. Okay, so what was your background? Why did you decide I want to build a robot?
I come from the food industry, so I was really close to owning a Chick-fil-A a long time ago.
Oh, cool.
And I started there when I was 14. I went through that whole process, and I just have this deep connection to giving food. Healthy food creates positive memories, and it can really make your body thrive. And so I eventually got an undergrad in business management and a master's in healthcare administration, and then came back to the farm after my grandparents got sick and all of our community was disappearing. So we said, forget that stuff. Let's figure out how to solve this problem. And 7 years later, we built a robot and an incredible team of engineers and started with just the three of us and middle of nowhere. So
and is the stage you're at now and what you're doing here, is this a prototype or is this like really close to a commercial unit?
This is commercial except for a few things. So
okay.
We have farmers who have purchased this unit and are running it all over Colorado, and then we have our trials in Arkansas, Oregon, and a couple other places. We will make modifications and we'll replace this unit for the farmers, but we have farmers who are bought into the approach, the tool, the method, and so now we just need to make our software better and figure out how to scale it at this point.
So the robot is already being used on farms, but they're still refining how it operates in different field conditions.
What are the tasks you're doing here? Are you verifying? What's the...
Yeah, so our farmers have said, the data collection aspects, those things are helpful, but it's not the solution. So we are focused on the hardest thing, which is the precision weeding between the plant.
Okay.
And that is computer vision driven for the implement, but then the robot is also autonomous. So that's kind of the blend and the mesh that we are one of few companies to have figured out. Eventually here, we might do some cultivation. We can do some precision spraying. This is an organic farm, so we're avoiding that, but right across the street in our soybean farm, we could deploy the same robot and reduce the amount of chemical input by doing a precision weeding tool instead of a mechanical weeding tool.
And so could you tell us briefly about a little bit about the tractor itself, and then also what all you've got going here in the truck with your team?
Yeah,
too?
yeah. So the tractor is just going to run. Right now we have it in the interface. They are operating from the laptop, and so the farmer will control the robot, and it will, at the end of the row, send us a notification when it's done. From the laptop, they'll say, go do the next one, and we'll just do that all day long. For the robot itself or the tractor, you don't need anything, so you just come to the field, you set up your GPS unit so that you can get your corrections, and then the computer vision takes care of the row itself. And then the truck holds the stuff on top, so we have a better connection, but otherwise you don't even need the truck here. So it's off connected, and you can take it anywhere. You can deploy it at any time as long as you have battery. And then you put it in your truck and you take it from field to field, and you do all the precision weeding or the precision tasks that you need.
Yeah, so when we saw you pulling in, we didn't know we were following, but it was just literally in the bed of your truck, and you unloaded it with ATV ramps.
Yep. Yeah, and it's super easy. Kelly and Sean will use a little trailer to transport it from point A to point B, but we designed it this way so it would fit in the back of a truck and be able to be on farm quickly, removed quickly, and not a hassle.
Well, and for our listener, it looks sort of like the size of a very small riding mower, right? Sits up high, kind of almost spider looking, I think, in terms of the way it's, or it's like a toy golf cart version of a sprayer almost, right? I would say. And so it doesn't look like you need a lot of manpower to move it around, or you can just probably throw it in the back of a Yukon or something almost, right?
Yeah, we fit it in a Tacoma. We fit it in all of these vehicles. And it fits in the back of a truck with a topper on it if you remove the antenna, but we'll fix that so that we don't have to for next year. So it's little things like that will make more efficient.
You said you were talking to how large is this field, and how many robots do you think, once this is fully going, how many robots would they need to service the weeds in this field?
Yes, we'd have to look at the map for an exact number, but it's between 100 and 120 acres in this field. We would need 3 robots to run the whole precision weeding on a 12 to 16-hour day. In this sweet potato field right now, it's a little cleaner, so we could go even faster. And then the computer vision slows down when it has more weeding work to do. We would need 3 robots to run this field, and then they could take those 3 and move them from field to field. And in 2026, we'll have a triple row boom. So one robot will also be able to 2.5x the capacity, and we'll be able to do, with this field, the whole field with 2 robots in a 12-hour day.
So while one robot doesn't replace a tractor, multiple robots working together could eventually handle a lot of field work.
What's the weirdest or strangest story you have from doing this job, experience that you've had?
I think it's just the robots in general. So you'll have everything super stable 10 minutes down the road, and then you'll pack it up and you'll come to a different location and something will happen. One time we had, and this was just the dumb thing, but one time we had one of our interns leave a controller in the robot. You turned it on and the thing climbed up a wall. So,
no way.
Yeah, in the back of a trailer. And so we have the power, we have the things, but it's just, getting it in the field. Like I mentioned, robots in the wild.
Yeah.
You don't see many applications of scale for the robots yet. And so we're all figuring it out. And I think it's just sometimes they're crazy and they have a mind of their own, but we have safety sensors and things that prevent that from the field, but not in the trailer.
Yeah,
so.
sure. Yeah. Man, thanks so much.
Thanks for coming out to the farm. It's always great to have other people here.
Yeah.
One of the most interesting things about technology like this is that it shows us how many different directions innovation in agriculture can go. From irrigation systems and research stations to robotics and automation, there are a lot of people working on new tools to help farmers manage labor, improve efficiency, and keep operations running. On our trip through the Delta, we were able to see several examples of that firsthand. Next week on the podcast, we'll shift back to the farm level and share a conversation with a rice farmer from the region, where we talk about what it actually takes to grow rice in the Mississippi Delta, from irrigation and crop management to the economics to make the system work. If you've mostly farmed in different regions, some of these differences might surprise you. So be sure to subscribe to the Purdue Commercial AgCast and join us next week for that conversation. Thanks for listening, and we'll see you next week.